Welcome back, guys. So this is the question number 5, and here again we have to calculate the total impedances of the circuits given in 15.124. Here we have to express our answer in the rectangular and polar form, and also draw the impedance diagram. Okay, so basically the circuits here are the what we have recently in our question, but what we have to do here some of the questions are somehow different, and we are going to use the same formulation which we have previously developed in our video. So let us calculate the impedance in our, let me change the color here. Okay, so that is A, and here again ZA is basically the, I have told you that first of all you have to see that how many resistors do I have in the circuit. So here I have only one resistor, similarly one inductor with inductive reactance. What we have to do, I have to put J with it, so writing X of L here, and similarly I also have a capacitor here as well, so writing minus J with the capacitive reactance here. So what will happen, writing it Z of A will be equal to the 3 plus J, X of L is 4, and that is minus J, X of C is 5. Okay, so now writing their values, let me go down here and writing their values, what I will get here, I will get here that the value of Z of A is 3 will remain same here because no real term, no other real term is available here, and also subtracting this minus this 5 from 4, what I will get here minus J 1. Okay, so ultimately I will have Z of A, the value of which is 3 minus J. Okay, so that is the answer in rectangular coordinate system. Converting it into the polar form, what I have to do, I am not going to go to the manual method again and going to do it here. So 3 minus 1 and writing iota with it, that is in the rectangular coordinate system. Converting it into the polar form, let me press shift here, and complex, in complex I have to press 3 and it will give me the answer, and converting into the feasible form I will get 3.16. so that would be 3.16, and the angle here will be minus 18.43. minus 18.43 degrees is the angle associated with it, and that is in ohm. Okay, so from it you can very clearly see that this is basically the rectangular form. Okay, while this one is the polar form, and you can very easily see that as this circuit is composed of the capacitor and inductor as well, but the nature of this circuit will be capacitive nature. Why? Because the negative sign with this imaginary term will basically illustrate us that which type of circuit will we have, and here we have this circuit and the nature of this circuit will be capacitive nature. Okay, because it is there is a negative sign with this J. Okay, similarly in order to calculate the values here in our B circuit here, let me solve it here. So again writing all the values here, so again seeing that how many resistors, capacitors and inductors do I have here. So I have only one resistor, let me call it ZB, so only one resistor. Similarly 2 inductors here, so J XL1 plus XL2, and similarly only one capacitor, so only one capacitive reactance is also here. So writing the capacitive reactance I have to put here minus J, so minus J XC. Writing values here, I will get here 1K or 1000 plus J, and value of XL1 is 2K, value of XL2 is 6K, so that would be 8K. Okay, I am simplifying it, so minus J here, and the value of X of C is 4K. Okay, so now again simplifying it, what I will get here 1K, and subtracting 4K from this 8K, what I will get here J 4K. Okay, so now it is basically in the rectangular form. So we can see that here we have different elements. Here we have the inductive reactances, we have the capacitive reactance, and we can very easily see that the nature of this circuit is now inductive because of this positive J in this impedance. Okay, so positive J, the sign of positive is now connected with this J term, and it illustrates that the nature of our circuit is the inductive nature. Similarly, in order to convert it into the polar form, let me go back here again and writing here 1000 plus 4000 and putting iota with it, I will get this one. Okay, now converting it into the polar form, let me put here 2 and now here 3. Okay, so here we will see that this is 4123.10, 4123.10. Okay, and the angle with it is, let me move here further, and 75.96 degrees. Okay, so that is in ohm, and we can clearly see that this is in the polar form. So both of these forms are now calculated. Similarly, in calculating our values for this circuit, here we can very clearly see that the capacitances and inductances are basically given in the form, and we don't have any value for XL and XC. We don't have these values. So first of all, we have to calculate these values, and we know that the value of XL is basically the omega L, which is 2 pi FL, and the value of XC is 1 over omega C, and that is 1 over 2 pi f c. Okay, so let me first calculate the value of omega. So the value of omega is the 2 pi f, and the value of the frequency is also given here, and that is 1 kilohertz. Okay, you can very easily see here that the value of frequency is 1000. So now calculating it, so 1000 multiplied by 2000 multiplied by 2 will be 2000 multiplied by 3.14. Okay, so that would be 6280. Okay, so that would be omega is 6280 radians per second. So that is the omega, and from it we can very easily calculate our values, which are XL and XC. So here the first XL is here, this is the XL1, this is the XL2, or let me write them in any other color, so writing in them in green. So that is now XL1, that is XL2, and that is XC1. Okay, so only one capacitor we have here. So let me calculate them, and let me go down first seeing that what are the values. So the value of L1 is 40 millihenry. So calculating it, now let me calculate it here. So the value of XL1 will be omega is 6280, and that would be multiplied with the L1 here, which is 40 into 10 raised to power minus 3. Okay, so now calculating it here, 6280 multiplied by what? Multiplied by 40. Okay, so that is this one. Now dividing it over 1000. So what I will get? I will get this one, and this will be 251.2 ohm. So that is basically the XL1. Now calculating the value of XC1, what I will have here? I will have here omega, so 6280 multiplied by the value of the capacitance here, and that is basically 0.1 into 10 raised to power minus 6. Okay, so these are the values. So bringing it over here, so this would be 10 is power 6 divided by this will be 628. Okay, so 10 is power 6 divided by 628 is how much? 1 2 3 4 5 6 divided by the 628. Here the value will be 1592.4. 1592.4 ohm, and that is basically the value of XC1. Okay, now calculating the value of XL2. So the value of XL2 is again omega L2. So the value of omega is 6280 multiplied by the value which is 200 into 10 to the power minus 6. Sorry, 10 to the power minus 3. Okay, so now 6280 multiplied by 200, okay, and divided by the 1000, what I will get here? 1256. Okay, so here it will be 1256 ohm. So that is the value of XL2. So we have calculated all our values which were needed. The first value is here, which is XL1, because no XL1 was given, and you can see that here it is L1, C and L2. So first of all we have to calculate the reactances, and the first reactance here, second one is XC2, third one is here. We have calculated these values. Okay, and now let me use them in our question here. So in calculating the total impedance here, what we have to do, again the same procedure. So this is part C, and let me call it ZC, and here we have to add the resistor, as we have only one resistor here. Similarly, the plus sign with all the inductive reactances. So we have two inductive reactances which are XL1 plus XL2, okay, and only one capacitive reactance, and that is XC1. Okay, so now putting their values here, now let me see that what were those values. So the resistance was of 470 ohm. So writing 470 here plus J, the value of XL1 was, it was basically 251.2 ohm. Okay, and the value of XL2 was, how much is it? XL2 was 1256. Okay, we have calculated it here. Okay, this one 1256. Now moving down, 1250. Okay, so now minus J and XCI. So the value of XCI is 1592.4. okay, 1592.4, and this is for XCI. So 1592.4 and this one. Okay, so now writing values here, 470 plus J, simplifying it, 251.2 and 1256, how much would it be? So 251.2 plus 1256, how much would it be? So it would be 1507.2. 07.2, and subtracting from it this one, 1592 from 0.4. okay, so now we have this quantity which is 1507.2, and we have to subtract from it the 1592.4 to solve or to simplify this equation here. So let me subtract from it 1592.4. okay, So here I will have minus 85.2, so 470, and this is now as minus, so minus j 85.2, yes, 85.2. So this is the value of z of c, and we can very easily see that the dominant term of j here is basically the negative. So the nature of this circuit will be the capacitive. Okay. So now converting it into the polar form, what I can see here, that in polar form what we will have, we have 470 minus 85.2 and with it iota. So that is the value, simplifying in this one, and converting it into the polar form, I have to go over this complex here and pressing 3 here. What I will get? I will get 477 again, 477 point what? 477.66. Okay, and the angle is minus 10 point how much? Let me look at for it here. So 27.27 degrees. Okay, so that is in polar form, and by plotting it over the complex plane, we will see that it will be somehow, let me plot it here. My drawing is not that much good, so plotting it here, I will see that the angle it will make will be the clockwise, and the clockwise angle here. So the values here will be 477.66 and the negative will be 10.27. Okay. So why this negative is basically in the fourth quadrant? Because whenever we will have the positive angle, all the terms will be here and the rotation will be the counterclockwise. Similarly, if you want to see, or if you have any negative angle here, how would we represent it? We will basically go clockwise from here. Okay. In another form, we can also represent it by subtracting it. If we have any negative angle, we can subtract it from the 360, and the whatever answer we will have, we will plot it in the counter clock as well. So you will see that the same angle we will have while plotting our phasor here. If we are plotting it in the negative form, or we are subtracting it from 360 first and plotting it then. Okay. So that is all about it, in which we have seen many applications of the impedance calculations, and I hope it will be enough for you for today. Thank you so much, and I will see you with some more videos.